The purpose of this video is to answer the question, what is a radian? Now, your calculator by default operates in radians, and when you, for instance, if you type in sine of 40 degrees, it converts the 40 degrees into radians and then finds the sine of it. So there's something going on in the background here that we really should look at, and that is, what is a radian? So I'm actually going to go to sharing my screen here and looking at this GeoGebra document which I created. Now, it is a unit circle, so it's radius of 1. And if you notice here, the radius, of course, the length of that line is 1. 44.33 degrees is actually the size of this angle. However, notice that also 44.33 degrees is the length of that, and 0.77 is the length of this line here. This is the size of the angle in radians. The radian measure is simply the length of that line there, the length of that arc. So as in radian mode, what would be true is that the cosine of 0.77 would be 0.72. And of course, the sine of 0.77 would be 0.7. That's if you had the calculator in radian mode. Of course, if you had it in degree mode, the sine of 44.33 would be 0.7, and the cosine of 44.33 would be 0.72. But let's just take a look what happens if we make the angle bigger. And of course, if we get up to about there, notice that the size of the length of this green line is now 1. That's actually the number of radians. So 1 radian is roughly 57 degrees. We kept going, 1.2, and so on, all the way up to roughly here. That's 2 radians. 2 radians, notice the length of the green line is 2. So that means that 2 radians is roughly equal to 114 degrees, as you would expect. It's twice as much as it was before. Now, if we keep going, 3 radians will bring us down to a point somewhere here. And of course, that's just shy of 180 degrees. If we kept going, 3.14159 radians would be right there at 180 degrees. And of course, GeoGebra switched and said, that's pi radians. Well, actually, it's giving the length of the green line as pi, but that means that 180 degrees is pi radians. If we were to go all the way around here somewhere, roughly there, that's 6 radians. So the length of the green line is 6. And of course, if we kept going, we'd end up at 2 pi, which of course would be 360 degrees. Of course, at that point, we're back at 0 again. And so that's actually what's happening there. Now, the thing to notice here and the thing to be aware of is 180 degrees was pi radians. It's actually 3.14159 radians. And I trust that that clarifies why pi is linked into it, and it's because it's 180 degrees is actually 3.14159 radians. Thank you for that. All the best with this topic.